Good morning, students. It is Physics 12th, chapter number 6, lecture number 4. And today's topic is mutual inductance. We have already studied about the self-inductance. Now we will discuss about the mutual inductance. It is a coil. Supply is connected. This coil is called primary. Now secondary. This one is secondary. This is secondary. In primary we can connect a DC supply or AC supply. You have not studied about the AC, you will discuss AC, we will study AC in next chapter, so I am taking only DC supply. So in this case, when this key will be inserted, then current will start to increase in this primary coil. Due to that, there will be change in the flux in the primary. So there will be induced EMF in the secondary because there will be change in the flux in the secondary as well. So due to change in the flux, there will be induced EMF in the secondary. Now what is mutual inductance? An opposing EMF is produced in a coil due to change in magnetic flux in neighboring coil is called mutual inductance. And flux in the secondary will be proportional to current in the primary. I am repeating again, an opposing EMF is produced in the secondary coil due to change in the magnetic flux in the primary coil, or you can say neighboring coil, is called mutual inductance. This phenomena is called mutual inductance. Now, it will be equal to Mi. M is coefficient of proportionality, and it is called coefficient of mutual inductance. If I is 1 ampere, then this flux will be equal to M. So you can define coefficient of mutual inductance. So mutual inductance is numerically equal to flux associated with the secondary when 1 ampere current is passing through primary. If 1 ampere current is passing through this primary, then how much flux is associated with the secondary? That is its mutual inductance. That will be numerically equal to mutual inductance. Now, we know flux is equal to Mi. So now I will differentiate it with respect to time. So d phi by dt will be equal to M di upon dt. That is first equation. And we know that induced EMF is minus d phi by dt. It is our second equation. So from first and second equation, induced EMF will be equal to minus M di by dt. I am neglecting this negative sign, I am just taking the magnitude. So magnitude of E will be equal to M di by dt. So that will be magnitude of induced EMF in the secondary due to change in the current in the primary. And in this case, because it is a DC supply, when we will insert this key, then there will be change in the flux in the primary. So it will take some time in acquiring the saturation value of the current. So magnetic field will change from 0 to maximum or 0 to saturation value. So induced EMF will be only for that interval of time in the secondary. Induced EMF will be only for that interval. Now, in this equation, if di by dt, that is rate of change of current, is equal to 1 ampere per second, then magnitude of E will be equal to coefficient of mutual inductance. So again, you can define the coefficient of mutual inductance. It is numerically equal to induced EMF in the secondary when rate of change of current in the primary is 1 ampere per second. So if in the primary rate of change of current is 1 ampere per second, then induced EMF in the secondary will be numerically equal to coefficient of mutual inductance. Now, our equation was, our E was, magnitude of E, that is, was m di by dt. So from this expression, m will be E upon di by dt. And if I assume that if di by dt is equal to 1 ampere per second, in that case, M will be equal to E. And if E is also 1 volt, then this M will become 1. And unit of inductance is Henry, so that will be 1 Henry. Now you can define 1 Henry. How will you define 1 Henry? So mutual inductance of two coils will be 1 Henry if 1 volt EMF is induced in the secondary. If this 1 volt EMF is induced in the secondary, when rate of change of current in the primary is 1 ampere per second. That is, if rate of change of current in the primary is 1 ampere per second and in secondary 1 volt EMF is induced, then mutual inductance of those two coils will be 1 Henry. Now we will discuss mutual inductance of two long solenoids. Mutual inductance of two long solenoids. This is the first solenoid. And this is second. It is primary. This length is L. Number of turns per unit length are N1. N1 are the number of turns per unit length in this primary. Then there is secondary. Number of turns in secondary, it is secondary. Number of turns per unit length are N2. Area of cross section of these two coils is A. So A is the area of cross section. Now we know that flux will be equal to Mi. So flux in 2 due to 1. That will be M21 into I1. Suppose I1 current is flowing through this. M21 mutual inductance of 2 with respect to 1. Now magnetic field in first solenoid, that will be mu 0 N1 I1. We know that magnetic field in a solenoid is given by mu 0 and I, so it will be mu 0 N1 I1. That will be B1. So flux in one turn of the secondary. That will be equal to B1A so that will be equal to B1 is mu 0 N1 I1 into A. Total number of turns in secondary are N to L. So for N to L turns, flux will be mu 0 N1 I1A into N to L. So you can say it will be equal to mu 0 N1 N2 I1AL, and flux was also equal to, it was flux in 2 due to 1, and flux in 2 due to 1 was, so if I compare these two equations, then coefficient of mutual inductance of 2 with respect to 1, that will be equal to mu 0 N1 N2 AL. That will be mutual inductance of coil 2 with respect to 1. Similarly, if I want to calculate mutual inductance of 1 with respect to 2, that will also be same. Now our next topic is AC generator. AC generator. Is it North Pole? That one is South Pole. And coil is placed in between. It is axis on which it can rotate. These are two magnets, North Pole and South Pole. This is the coil which is placed in between the magnetic field, and this coil can rotate on this axis, and we will get AC output here between these two terminals. These are brushes, carbon brushes, and these are slip rings. These are slip rings. This coil is like this. This is the coil. It is placed in this magnetic field and this coil will rotate like this. So due to rotation, there will be continuous change in the flux in this coil. There will be continuous change in the flux in this coil. So due to change in the flux in the coil, there will be induced EMF. Now question is, what is the principle? Principle of a AC generator is, if there will be change in the flux in a coil, then there will be induced EMF. And because in this case there is a continuous change in the flux, so induced EMF will also be continuous. Suppose this is sense of rotation, it is rotating like this. So this is the coil. This axis is rotating like this. It is rotating like this. Like this. So this is sense of rotation. It is rotating like this. This coil is rotating like this. It is, suppose this is the coil and it is rotating like this. Now what will be direction of the induced EMF? It is rotating like this. Focus on this side. This side is coming in upward direction. It means that external agency is applying some force due to which it is moving in upward direction. This is direction of magnetic field. This is direction of magnetic field. Now this coil is coming in upward direction. So due to induced current, force should be in opposite direction according to Lenz's rule. Because what is Lenz's rule? The direction of induced current will be such that it will oppose the cause which is producing it. Now my fingers are giving direction to the magnetic field, force should be downward, so my palm is giving direction to force, then thumb will give direction to the current. So that will be direction of the current. So direction of induced current will be like this. Suppose I say it is A, it is B, it is C, it is D. So that will be direction of the induced current. Now, what will be magnitude of this induced current? And from where we are getting energy? External agency is rotating this coil. So that external agency will have to do some work. In case of AC generator, generally engine rotates this armature. So that engine does external mechanical work and that mechanical work will be converted into electric energy. So this is the source of energy. Now we know that flux is equal to B dot A. Suppose this coil is rotating with angular velocity omega. So in any time t, angle theta will be omega t. So at any time t, angle between B and A will be omega t. So flux will be BA cos omega t. It is for 1 ton. Suppose there are n tons. So in that case, this flux will become, for n tons, this flux will become NBA cos omega t. So flux will be NBA cos omega t at any time t, that will be the flux. Now we know that the rate of change of flux is equal to induced EMF. So induced EMF will be equal to minus d phi by dt minus d by dt of NBA cos omega t. N, B and A all are constants. Differentiation of cos theta is minus sin theta, so minus minus it will become plus. So it will be sin omega t, and differentiation of omega t is omega, so it will be multiplied by omega. So induced EMF will be given by NBA omega sin omega t. So induced EMF will be equal to NBA omega sin omega t. Now n number of turns, total number of turns, B magnetic field, A area of this coil, omega angular velocity, all are constants. It means induced EMF will be function of sin omega t, that is it will be function of sin theta. So what will be graph? Along this I am taking T or omega t, along this induced EMF. Because it is a function of sin theta, so shape will be like this. It is a graph for sin theta, so 0 to maximum, then it will decrease, will become 0, then negative maximum, then again 0. In same way, current will also vary. Now, how it will become negative? So that, focus on this. This side is AB, this side is CD. In AB direction the current is upward, in CD direction the current is downward. Suppose I say it is AB. This side is AB. Direction of the current is upward. Now I am rotating it. 90-degree rotation, 180-degree rotation. After 180-degree, now this side, now what was direction of current in this side? It was downward. So initially, in this branch or in this side, direction of the current was upward. After 180-degree rotation, this direction will become downward. So direction of the current will be reversed after 180-degree. It is 0, pi by 2, pi, 3 by 2 pi, and 2 pi. So after 180-degree, direction of the current will be reversed. Due to that reason, it is called alternating current. Positive, negative, repeatedly positive and negative cycles. So it is called alternating current. So this is the working of AC generator. Now that was the last topic of this chapter. Now you can solve the remaining numericals, remaining NCERT numericals of this chapter. Thank you.